Namaste. Today we will talk about remote sensing, what, why and how. So all of us mounted with one device, a sensor which is working in electromagnetic spectrum, right? We call it eyes, right? Then we have another device, the camera, which can sense the reflected electromagnetic signals and capture it as an image. And one more thing, we know that the satellites. All the satellites are mounted with a sensor, correct? They are capable of collecting information about Earth's surface using electromagnetic spectrum. Okay, it's a device mounted in the satellite to collect information about Earth's surface feature. We call this a sensor. Okay, then what is remote sensing? Remote sensing can be defined like this. Remote sensing is a science and art of obtaining information about an object, area or phenomenon through the analysis of a data acquired by a device that is not in contact with the object, area or phenomenon under investigation. And we all know that there are different types of satellites, geostationary satellites and polar orbiting satellites. The altitude of geostationary satellite is 36,000 kilometer. And what about the altitude of remote sensing satellites? The altitude of remote sensing satellite is 1,000 kilometer. And all these remote sensing satellites are polar orbiting satellite. That means they move from pole to pole. This is how the polar orbiting satellites orbit around the Earth. Then how these polar orbiting satellites, a sensor mounted in the polar orbiting satellites, collect information about the Earth. We can see that the sensor mounted in the remote sensing satellite scan the Earth surface feature as shown in the slide. And all these sensors are working in they sense the reflected electromagnetic spectrum from the Earth surface feature. Then who is the natural source of electromagnetic spectrum? The sun. We know that sun is a natural source of electromagnetic spectrum. The radiation, the electromagnetic spectrum, radiation that is reflected by the Earth surface feature can be sensed by the sensor. Okay, there are two types of remote sensing. Okay, the active remote sensing. In this case, the sensor uses its own source to illuminate Earth surface feature. For example, the flash camera, right, that uses the flashlight to illuminate the objects. But here the radar kind of or lidar or radar, they use their own source to reflect the Earth, illuminate the Earth surface feature. And another type of remote sensing is passive remote sensing. Most of the remote sensing system is a passive remote sensing system. Here the sensor uses naturally available electromagnetic radiation, right, that is from the sun. And once you understand most of the sensor uses the naturally available electromagnetic spectrum, then we must understand about something about the electromagnetic spectrum. Right? This is the picture of electromagnetic spectrum. Right? We can see in this the region which is shaded are very useful in a remote sensing system. Right from the visible region of electromagnetic spectrum to the microwave. This region of electromagnetic spectrum is useful in a remote sensing. Okay, we can see further, we can see the human eye is sensitive in a very narrow region of electromagnetic spectrum from 0.4 to 0.7 micrometer. Then the photography vision is slightly bigger than our human eye. It can sense nearly ultraviolet to near infrared. However, the thermal scanners, they can sense the thermal region of electromagnetic spectrum. However, the sensors mounted in the satellites, they can sense right from the visible region to the thermal region. It has wide range of collecting information in a EMR spectrum. Then this is how the energy reflect from the Earth surface feature. We say our eye is designed to sense electromagnetic spectrum in a visible region. So that that's why because the maximum energy reflectance for the sun's radiation is in the visible region. You can see from 0.4 micrometer to 0.7 micrometer region is very high reflectance for sun's radiation. That is why our eyes are sensitive in this region. However, the energy reflectance from the surface in infrared thermal region is comparatively less. Okay. And you also know that Earth can also emit its own radiation in a thermal region. Okay. This is very important to remember in remote sensing. And you can see the transmission of radiation. See, in a remote sensing, all Earth surface feature emits the radiation or reflect the radiation, but the reflected radiation is trapped by the various gases present in the atmosphere. The transmissivity of the gases are very important in remote sensing. For example, visible region has more than 90% of transmission, nearly 98% of transmission. That is why we can have sensor in this region. Okay. And also in the infrared region, there is transmissivity. Again, there is a thermal region, there is a transmissivity. Okay. The remote sensing technician or scientist want to understand where there is transmission of radiation in the electromagnetic spectrum. It is very important. These regions are known as atmospheric window, where there is highest transmission of electromagnetic radiation. For example, these are the various, in a visible region you can say, have one atmospheric window, in near infrared you have, as well as in thermal region also you have a window, right. See, these are the sensors. Okay, you know, the sensor is developed to collect information in the visible region and near infrared region of the electromagnetic spectrum. Okay, then in the again there are two bands in the near infrared and thermal region of electromagnetic spectrum, as well as in the in the thermal region of electromagnetic spectrum we have the sensors. Okay. It's about basics of remote sensing. In the next class, we will discuss in detail. Thank you.